find the point of inflection for f of x equals x cubed minus 3x squared. Now, the first thing we want to note is at the point of inflection, the second derivative will equal 0. And also, on one side of the x value, the second derivative will be positive, and on the other side, it will be negative. So first, let's find the point of inflection. So if you do the first derivative, we're going to get 3x to the power of 3 minus 1, which is 2, minus 3 times 2, which is 6, x to the power of 1. And the second derivative is going to be 3 times 2, which is 6, x to the power of 1, minus 6x will derive just to 6. So now we want to know when this equals 0. So we're going to do 0 equals 6x minus 6. Adding 6 on both sides, we're going to get 6 equals 6x. Dividing by 6, we'll get x equals 1. So our point of inflection is at x equals 1. Now we also need to make sure that the second derivative on one side of x is positive and on the other side it's negative. So say we sub in 2 in here, well, then what we're going to get is 6 times 2 minus 6, which is 12 minus 6, which is 6, and we can see that that's positive. And if we can also sub in, say 0, then we're going to get 6 times 0 minus 6, which is going to be negative 6. So that's negative at 0. Then at x equals 1, we have the second derivative equaling 0. And then when x is greater than 1, say at 2, then it's positive. So this is the graph here. And we can see that at x equals 1, that falls somewhere around here, that we have our point of inflection. So remember, at the point of inflection, our graph changes from concave down to concave up, or from concave up to concave down. So in this, our second question is state the interval where the curve is concave up. Well, just looking at the graph, we can see that here, it starts becoming, that's concave up. And algebraically, if you didn't have the graph drawn, when the graph is concave up, the second derivative is greater than 0. So as we already found out that when x is greater than 1, so say when x was 2, we had a positive second derivative. So we can say the interval is concave up starting at x equals 1, and then it keeps doing that forever. So the interval for it being concave up is going to be from 1 to infinity.